from solving systems of linear equations. It's back, and we're going to solve it. We're going to knock out this thing that was way too difficult for us then. It's going to be a piece of cake for us now because we've got access to how inverse matrices work. We can use calculators to be able to calculate an inverse matrix very quickly. This thing's going to be a cinch. Our game plan, remember the idea was that we have the coefficient matrix A times the column of the variables is equal to the column of the constants. So AX equals B. If we can figure out what A inverse is, we can multiply by A inverse on the left side on both cases. A inverse cancels out there, and we're left with X equals A inverse times B. We already know what B is. B is this thing right here, so that part's pretty easy. Can we figure out what A inverse is? Well, this is A. So we've got access to a graphing calculator. I'm assuming we have access to a graphing calculator, some way to do matrix calculations. Once again, matrix calculations, easy to do, but crazy tedious. They take all of this time. It's easy to make a mistake because just doing 100 calculations, you tend to make a mistake in there. But that's what calculators, that's what computers are for. That's why humans invented those sorts of things, is to be able to make tedious calculations like that go away, where we can trust the calculator to do the, number crunching part, and we can trust us to do the thinking part, hopefully. So we figure out what is A. So we figure out A is, it's going to be a big one, our U's first. 1U, negative 4U, 1U, negative 2, 1/5 U, 2U. Next up our V's. 2V, 2V, 1V, 1/2 V, negative 3V, positive 4V. 7W, 1W, 0W because it didn't show up. 3W, negative 1W, negative 1W. Negative 3x, 1/3 x, 0x, 0x, 2x, negative 3x. 4y, 2y, 1y, 2y, negative 1y, 5y, 2z, 1z, 1z, 4z, 4z, 0z. So what you do is you take A and you enter that into your graphing calculator, right? You put that into a graphing calculator, you put that into some sort of matrix calculator. So you enter this into a calculator or a computer or something that is able to work with matrices. Lots of programs are, because matrices are crazy useful. Once again, we aren't even beginning to scratch the surface of how useful they are. We're just getting some sense with this one problem. So you enter this whole thing into a calculator. Then you tell the calculator, take the inverse. So we do that, and I want to point out, before we actually go on to talk about the inverse, you tell the calculator, take the inverse. Before you do that, double check that you entered the matrix correctly, right? If you entered this wrong, if you entered this big A, 6 by 6, that's 36 numbers that you just put into your calculator. Chances are you might have accidentally entered one of them wrong. You enter one of them wrong, your entire answer is going to get screwed up. Chances are it'll get screwed up and be this awful decimal number, so you go, well, my teacher probably didn't give me something that would come out to be an awful decimal number, but if you're working in something like physics where you don't already know what the answer is going to be, it's up to you to make sure you get it in correctly the first time. So double check. If you're entering a very large matrix, make certain that you entered that matrix correctly. So we've got the entire matrix set up in our calculator, and we've double checked that it's correct. Now we punch out A inverse. So on most calculators, that's going to wind up being, take the matrix, raise it to the -1. What does it come out to be? It comes out to be sinfully ugly. It is awful. For example, the very first term is going to be 1,780 divided by 14,131. The second column, first row, second column, would be 45 divided by 14,131. The third, this is awful. Ugh. So what are we going to wind up doing? We have to write the whole thing down. No, we don't have to write the whole thing down. It's in our calculator. We just tell the calculator A inverse, and then we don't have to worry about A inverse at all. We don't have to figure out and write the whole thing down on paper. There's no need for it. The calculator will keep track of what the numbers for A inverse are, because all we're concerned about is taking A inverse and applying it against B. So we leave in the calculator, we know X is going to be equal to A inverse times B. Right? That's what we just figured out from our game plan of thinking about this. So we have in our calculator, A inverse is in there. We have it in the calculator. We don't have to actually see what the whole thing is because it is already there. What is our B? We enter in the column matrix, 41, 39, 4, 23, negative 30, 44. We make sure that our A inverse is multiplying from the left side, otherwise it won't work at all. And what does this wind up coming out to be? This comes out to be the deliciously simple negative 5, 4, 1, negative 3, 6, negative 1. So we just figured out x equals our x as all of our variables at once. Well, x is equal to, what were all of our variables? It was u, and then we put in v, and then we put in w, and then we put in x, y, z. So they go that order in our column: u, v, w, x, y, z equals this thing that we just punched out: negative 5, 4, 1, negative 3, 6, negative 1. So u equals negative 5, v equals 4, w equals 1, x equals negative 3, y equals 6, z equals negative 1. If we really wanted to at this point, we can check it, right? We could plug each one of these into any one of these equations, and if it came out right, chances are we probably got the entire thing right. So it might not be a bad idea to check at that point. But also, as long as we were really careful with entering in our A and careful with entering in our column of constants, our B, everything should have worked out fine there. Otherwise, there's some other error that cropped up. So it becomes really, really easy with just a little bit of thinking and this calculator to take care of the awful grunt work of the numbers, of just having to crunch through that many numbers. As long as we've got the calculator to be able to do that part, so it's quick and easy and we can trust that it came out right, and we're able to do the thought of what's going on, we see that A inverse, our coefficient matrix inverted, times what the equations come out to be, our constant column matrix, just comes out to be the answers for each one of them. Really cool, really fast, really easy. So anytime you've got a large linear system or even a small linear system and you just want to check it, boom, you can have it done like that if you've got access to a matrix calculator. Pretty cool. All right, we'll see you at Educator.com later. Bye.